In this tutorial, we'll be going over background for standard heat of formation, a molar heat of formation. So what this is what scientists did was they created this tabulated data for various substances and measured their enthalpy of formation of various different substances. So um, so here's the definition. It says enthalpy change for equation in which 1 mole of a compound is formed from its elements in their standard most stable states. So for example, let's say you wanted to form 1 mole of NaCl. Okay, and this is so its standard most stable state. NaCl would exist as a solid. Okay, so standard state means how it would be at 25 degrees Celsius at 1 bar, which is about 1 atm. It's like 0.987 atm. And if you had 1 molar of the substance, so NaCl, you would not write like liquid. It would not be melted in its most stable standard state at 25 degrees Celsius. So it says the for which 1 mole of a compound is formed from its elements. So you have to take this completely literal. So from its elements in their standard most stable states. So the way to write a reaction then for this is to write NaCl from um, Na, which is solid sodium, plus, and the other element that this is composed of is chlorine. And chlorine, in its most stable standard state, is not Cl, it's actually Cl2. And at 25 degrees Celsius, Cl2 is a gas. We wouldn't write Cl2 solid or something like that. And notice this has to be balanced. This has to be 1 mole. This must be 1 mole by definition. So it says for which 1 mole of a compound. Okay, so in order to balance that, then we need to use a half right here. Okay, so use halves when needing to balance the reactant side. Okay, so let's look at these two questions here. Which equation represents a molar heat of formation? So where we have 1 mole of a compound formed from its elements in those elements standard most stable states. So I think you could see there are several things wrong with this first reaction. First of all, this is not good. That it's a so this potassium is a metal at room temperature, so this must be a solid at 25 degrees. Okay, and this is showing a liquid. This one is okay. It's a gas, but the other problem here is that this is 2 moles, so this must be 1 mole. Okay, so let's take a look at the next equation. So we have, so this is 1 mole, so this is okay. We have oxygen as a gas, this is okay. It's a gas at 25 degrees Celsius. H2, this is good, so this is okay. And carbon in its elemental form is a solid. Okay, technically this should actually say graphite because carbon in its solid form can have like different forms that it can be. But under its most stable state, it should be graphite. So if I had to pick one, this would be correct, number two. But technically, like I said, the carbon there, it should actually specify and say graphite. Okay, and then this is okay too because this is a liquid, so ethanol is a liquid at 25 C. Okay, change slides. So some other examples of standard states. So or what? Okay, because how do I know? Okay, so how do I know that this? How do I know that this is supposed to be a solid? Okay, I know metals. There's only one metal that's actually a liquid at room temperature. And how do I know that there's supposed to be two of these and not one? So there's a few things to know about what standard state means, like what these most stable state standard states are. So there's a few things that you may not know that I'm going to cover on this next slide. So some standard states that you should know are the following. So metals are solid except mercury, Hg, is a liquid at 25 degrees Celsius. So where are the metals? To the left of the staircase, basically. Diatomic gases, you'll need to know these so that you could recognize them because these seven elements, they exist diatomically in nature. They're never found by themselves. All other elements are found by themselves, okay, monotomically. So the diatomic gases or elements, you'll see that some of these are actually not gases. Um, these must be written as diatomic in their standard states. So five are gases. There's seven total. Five are gases. H2, N2, O2, F2, and Cl2. Okay, because of London dispersion forces, one of these is a liquid. So one is a liquid, and that would be Br2. So you would write that as a liquid, and then one is actually a solid, and that would be I2. And if you notice, that's because you're going down, so you're getting tons of electrons. By the time you get to iodine, you have I2 has 106 electrons. So at that point, the LDFs start getting really strong, and it starts becoming a solid. Some other things about these standard states, if you ever have carbon, its most standard state is graphite. So it should actually specify in the chemical reaction, it should actually say the word graphite, comma, S. And then another one is sulfur can have these different elemental sulfur can have these different geometries in the way it's put together. And the most stable one is a rhomboid. So you say rhombic, comma S. So a rhombic solid. Okay. So next slide is I have some practice on writing heats of formation. So it says write heats of formation equations for the following. I'm gonna do the first two, okay, and then I'm gonna have you guys try three and four. So for NaCl, I did this one on a previous slide. So make sure that you're showing 1 mole. Okay, 1 mole here, and it has these are from their most stable state. So use the previous slide that I just went over, okay, to get the correct states of matter. So I like to write arrow first, and then the actual substance. And in its most stable state, water should be a liquid. And the elements that it came from are hydrogen and oxygen. Okay, so now you just think about how to write hydrogen and oxygen in their most stable state. So it's not H, it's H2. It's one of the diatomics. And we write G for gas plus O2. Okay, and then always worry about the balancing last. So I need one oxygen over here, so I have to put a half in front. Okay, remember we can't change this number. That's why we have to use halves. Okay, in order to get 1 mole of compound on the right. All right, so that's the end of our tutorial. I'm gonna have you guys try three and four. Okay, so remember, let me give you a couple pointers. So remember to just think. Okay, so this is made of carbon, hydrogen, and then oxygen. So put those. Just add one. Go one by one. So go one by one. in the elements that compose this substance. Okay, and then you write those as your reactants. So you should have three reactants here. Okay, and then your product. Okay, and then do the same for number four.